Moving on to question 5. A landscape architect is planning a new nature area in the middle of an urban campus. She wants the length to be twice the width. And she wants to put a 3-foot high retaining wall around the perimeter. And there's 309 total feet of wall. All right, so here we have, this is the area that's going to have the wall around it. And if this is the width, that would make this the length. And we are told that the length is twice the width. The length is twice the width. So rather than put length here, I'm going to put 2 times width. Here's a width, 2 times the width. Here's the width, here's 2 times the width. So that's what my rectangle looks like. And we are told the perimeter around the outside is 309 feet. So 2 times the width, plus 2 times the width, plus the width, plus the width. That's adding up all 4 sides. That has to equal 309. Since these are all W's, we can combine like terms. 2, 4, 5, 6. 6 times the width, bring down the equals, bring down the 309. And to get width by itself, divide by 6. And we get that our width is 51.5 feet. So how big will the area be? How wide will this area be? The width is going to be 51.5 feet. If they had asked how big the length is, we would multiply that by 2 and we'd get 101. No, 103. So question number 6 says, adapt this procedure to solve the problem if the length is 3 times the width. So here's a width, and here's a width, and now my length is 3 times the width. But we still have 309 feet of fencing, so we're going to have 3W plus 3W plus W plus W. All 4 sides added together have to equal 309 feet of fencing. Adding these together, 3, 6, 7, 8, that means 8 times the width is equal to 309. So in this case, if the length is 3 times the width is 38.625 feet. Question number 7 says, a pool is being built in a new student rec center at this community college. The pool is designed to be 60-foot by 26-foot rectangle, and there's going to be a deck around the pool. It's going to be lined with 1-foot squares. All right, so here's 60 feet, and here's 26 feet. In fact, I think I want to put the 60 on the inside because I'm going to draw some squares on the outside. So here we have these tiles, 1-foot tiles on the outside of the pool, and the question is how many tiles are going to be needed? All right, so here's 1, 2, 3, and if these are a foot square, there are going to be 60 tiles here, and 60 tiles on this side. And if these are 1-foot square, there are going to be 26 tiles along this way, and along this way there'll be another 26 tiles. So you would think that there would be 60 plus 26 plus 60 plus 26. However, we need to add a tile here, and a tile here, and a tile here, and a tile here. In other words, there are 4 corner tiles not accounted for in the length and width of the pool. So how many tiles will we need? 60 plus 60, that gives us these. We're going to add the 26 and the 26, that gives us these. And then we're going to add our 4 corner tiles. So we would need 60 plus 60 plus 26 plus 26 plus 4 is 176 tiles to go around this pool. Now there's a follow-up question on this pool application. Generalize your result from question 7 to solve any kind of problem if there are 1-foot squares around. So our general formula would be number of tiles, so maybe we'll call that T, is going to equal 2 times the length of the pool, that takes the 2 sides of the length, plus 2 times the width of the pool, plus 4, because we're always going to need those 4 corner tiles.